Hello, everyone. Welcome to today's 12D Tech Forum 2024 Director's Cut webinar. My name is Lisa Stewart. This webinar series is designed to highlight some of the amazing content we wanted to include in our face-to-face event last year, but which just didn't fit into the programming. Some presentations you'll see were left out entirely, and others had to be cut short because we had too much content, which was a great problem to have. We'll be running these webinars until that excess material is exhausted and recording them for posting on our YouTube and Vimeo channels with links through our website. Our previous webinars from this series, as well as those from our other webinar series, are available online if you missed those. During this presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. Then at the end, I'll read out some of your questions to the presenter live if there's time. Today's webinar, 2D Water Analysis, will be presented by Dylan Revell, a Regional Sales Manager for 12DNZ with a wealth of experience in civil engineering practice, land development, drainage, and construction. Building on the user-friendly GUI of 12D Model's 2D Quick Analysis, the 2D Water Analysis tool extends the features and commands available for 2D modeling in 12D Model. Dylan will take you through this functionality to demonstrate how it can work for you. Over to you, Dylan.
Hello and welcome to the 12D Model Industry Solutions webinar on the 2D water analysis. I'll be running through a short PowerPoint slide and then getting into what you've actually come to see, which is the 2D water analysis in action. So what is the 2D water analysis? It builds on the user-friendly graphical interface of the 2D quick analysis, or the road flow as you may be familiar with the terminology. It extends these features and commands available for 2D modeling, but it's all contained within a nice 12D model interface and controlled dataset. We are still developing options, but you'll see that it's definitely ready for testing and user feedback, and I'll run through those options that are still under development a little later on. It's a single step processing, so if you've been using the 2D quick analysis to set up your models, and then using the TCF editor to expand on those limitations of the 2D quick analysis, you won't be doing that anymore. You'll be coming straight into the 2D water analysis for both the setup and all of your modeling requirements. And do ask a reseller about the modules available and what you may already be eligible for. A lot of you may be already familiar with the 2D quick analysis tools inside 12D. There's lots of videos, so operations like the graphing or the automatic legend creation, they're consistent with the new 2D water analysis, so I won't be running through those today. I'll be sticking just with the new features of the 2D water analysis. However, the 2D quick analysis is providing the building blocks for the 2D water analysis, and if you hear 2D QA or 2D WA, that's probably going to be the terminology going forward. Direct feedback from users of the 2D quick analysis have controlled a lot of the features that we've initially put into the 2D water analysis. It's come directly from their experience and their feedback. And some ambiguous panel phrasing has been made clearer, and I'll show you that once we get into the panel. So the 2D quick analysis had quite a few features. There were some limitations. So the limitation being the single and only rectangular domain, active area. We had the subgrid sampling, constant rainfall, direct rainfall on grid, so running your rainfall patterns on the grid, coupled 1D, 2D models. There was, however, a single constant boundary slope condition, and you had a maximum of 2 surface types. The model naming was user-defined, and the file names was automatically defined. So these experiences have led us into enhancing the 2D water analysis tools. So what extra can you expect from the 2D water analysis? Well, a lot of those limitations have been removed from the 2D quick analysis to the 2D water analysis. You can now have multiple user-defined active areas. You can have multiple boundary conditions, multiple defined materials, and you can have your user-defined output file types. And then we've added a whole heap of new features, which are the ones in blue, over and above what you can do within the 2D quick water analysis. Initial whole grid water levels, multiple independent defined rainfall areas, we have multiple user-defined initial water level areas, tailwater control models, spatial inflow points, and I will be showing you most of those today. There are, however, a few things that I won't be showing you, which will be coming in a follow-up as they are still under development, and those will be your multiple boundary conditions, your direct spatial inflow points, and your multiple tailwater control models. So we'll follow that up with a follow-on or a appendix for this presentation. Now the 2D sim file, everything runs on the simulation file. This gives you instant recall of all of the settings and values. We had user feedback. I can't remember what I filled in for this particular panel. I had to save it away into a default panel state. So the 2D sim file takes all of that pain away. It will automatically save all of the simulation settings when you run, or you can save it intermittently as you go. And it makes it very quick to create and store variations of a 2D analysis run. Every folder, file, and model name is automatically referenced to the sim file. Now this is really important because it makes it so much easier for yourself coming back to do a simulation later on, or more specifically for somebody picking up your project, can't remember what you had in all of your simulation files and where this model came from. It takes care of all of that for you. Now the graphical user interface, there's been some major enhancements here. We create and edit the control files for you, just like the 2D quick analysis. But all of this is done as a single panel operation, so there's no quick startup with a quick analysis and then a TCF editor. We are building all of that in the background for you as you go. We have automatic default values already pre-populated in the field, so if you want to change something you can, but you don't have to fill in a whole lot of fields before you can get a simulation underway. And we have really clever new model data edit panels that you'll see can have pre-populated values in them from the string data, or if you put an override into these new edit panels, it can actually go and update the data of the strings themselves. We have multi-line descriptive, i.e. actually helpful tooltips. And it's a context-driven option. So if you've got a particular value or a tick button set, you will see the options for that operation. If you don't have any settings for another operation, you won't see that option, or depending on the method that you're using. Okay, let's see it in action. I have a 12D model project here already open, and within that project I've got our tin that we want to run our simulation on, and I also have some other associated models that I'll run through step by step to show you how you can add those and enhance your 2D modeling experience within the 2D water analysis tools. So to fire up the 2D water analysis, it's under Water, Water 2D, and it's a new option on the version 15 menus called 2D Analysis. If you would like to start a new simulation, you can type in a new 2D simulations or a sim file name, or if you are coming back and running a simulation again, you can select that from the pre-populated list. So I'm going to enter a new simulation setting file name. I'm going to call this flood 2D only. And as soon as I hit enter, that's going to save that file and it's going to pull up the rest of the options within the 2D water analysis panel. So you notice that you can bring your own 2Flow dongle as you could within the TCF file editor, and the panel is nice and compact, and we'll be running through those tabs and options as we go. Obviously the first thing we need is the extents of our simulation. So I'm going to go as per the 2D quick analysis, and I'm going to start with a 3-point rectangle, and I'm going to pick that as the grid extent. As I enter in my cell size, it's automatically going to put in the subgrid sampling frequency, and then I just have to select the ground model that provides our ground tin. Now as you look further down in the panel, you'll see items there that are in a grey shade or a lighter grey colour. These are the pre-populated values. Those values will make sense, but you do have to obviously check that those are the values that you want. But anything in the panels that you see in a light grey colour is a pre-populated value, so you don't have to go and fill this in every single time that you create a simulation file or run a simulation. You can get going really, really quickly. So the other thing, a couple of things I need to do is just put in an initial Manning's End material value, and obviously I need some rain on that grid. So I'm going to go into the rainfall tab, and I'm just going to start with a constant rainfall. And as we go through, you'll see that a lot of this terminology has been tidied up, so it's less ambiguous, and that will allow, I guess, a lot easier application of understanding what's going on. That's all I need to enter to enable us to do our 2D water analysis simulation. So I'm going to go ahead and hit run. And I've chosen a cell size and a simulation time, so it's not going to be too onerous and you won't be sitting around twiddling your thumbs waiting for the analysis to finish. But when I do run the analysis, it's always a great time for you to perhaps take some notes and, more importantly, put in some questions that you'd like to ask after the completion of the demonstration. Okay, that run is finished normally. It comes up with the error warning report as we go through. I'm not going to get into too much detail of those. I'm just going to finish those as we go because we want to show you as many features as possible. And now that I've completed that simulation, I'm just going to read in the results, which is going to populate some predefined model names. Now, this is the important thing. Everything revolves around the simulation file name, which makes it so much easier for tracing and tracking where things were created from, which simulation settings that they had. So I've got a couple of views that I'm going to use as I go through the demonstration today. First up, I'm going to go to the plan results. When I go to the object tree model list, you'll see that the top level of the object tree is the sim file name, so I can start tracing exactly where that's come from. And if I expand that out, they're all object tree enabled. I think you'll find that they are much more descriptive names that you might be used to. So it just makes it that user experience a lot nicer. So I'll show you the common items for both a 1D and a 2D in a moment, but I'm just going to go to the results 2D because this is a 2D only run, and I'm going to add the 3D TMO grid tin model to that. And I'll do the same thing to the 3D view. So I'm going to add that results 2D, 3D. Okay, so this is the results of that initial simulation run. There is a number of check models that have been read in and some common check files as well. So I'm going to open or activate the check model view. I'm just going to move that to the left half of the screen, and I'm going to go back to the adding models in the model tree. So we do have some common check files that are common to both a 1D and a 2D, and I'll just add those on. Okay, so you can see those some check files. The grid tin is kind of obscuring everything else, so I'm going to remove that one, the surface grid tin, and then I'll go and open up the other check models. So if I just add all of the checks in the 2D. So we've got your check files, we've got all of your attributed as per the normal 12D operations, and under the results, I get to choose whether I'd like to read in the grid check file, the Z points check file, and the velocity check file. Now the interesting thing is in the outputs, if I did not ask to create those initially, I wouldn't be able to activate these values. But for now, I want to read in the grid check file so we can have a look at the extents as we start playing with the active areas. So I'm just going to read the results again. That's going to add in an additional model that I can add to that view, just to show me the results of the actual SGS grid operation. And the object tree that checks 2D, you'll again see that everything is a lot plainer text, so it makes it easier to understand what you are adding or removing from your views. And if I go back into the Outputs tab, spend a little bit more time in here, this is another one of the enhancements is you can choose which results types of files are created or not created. So that's under the map output format types. What I'd like to do is I'm going to turn on my water-eyed settings. And before I forget, while I'm in here, I'm actually just going to select my flow output points model, because I will definitely forget that later on. One of the major things that, or the major requests that we had over and above the 2D quick analysis is to not only have a rectangular active area. So if I go back into my inputs model, I'm going to start adding models and adding those to the simulations and run them as we go through. So I have a model here which has one polygon at this stage, or 3 polygons, but it's got an irregular shaped active area. This is the area that I want my simulation to run on, as opposed to that larger rectangle. And I also have a couple of internal polygons that I want to set as inactive areas. So under the Geometry tab, under the active areas, I can specify a model that overrides the initial extents value. So if I select that 2D active area, it's going to scan that model for the strings or the objects that are inside it, and it gives me the ability to either accept some pre-populated values or to edit those strings within the panel itself. So I have 3 polygons, the overall 2D area, that's active, and I have 2 internal polygons that I essentially want to turn the cells off in that area. So if I right click, and I'm going to change those 2 smaller initial polygons to inactive. And if I go ahead and set that and finish, come back into the check model, because we're going to go see what's happened after I do the run, and I'm just going to go and run that simulation again. Alright, that simulation's completed. I'm just going to finish that output window in the background. These are the previous active areas in the grid extents that was applied with the simulation before I chose and edited that active areas model. So I'm going to read the results again, and what you'll quite clearly see, redraw that view, is the simulation area has changed to that irregular polygon, and the polygons that I set as inactive areas have essentially been turned off within the model. And if I go to the plan results itself, you'll see that I quite clearly have areas within the simulation extents or domain that have now essentially been ignored. So the constant rainfall is being applied to essentially everything within that grid. What about if I wanted to have different rainfall areas with potentially different rainfall values or settings? If I go back into my inputs, I'm going to add another model which has my defined rainfall areas. And back in the Geometry tab, I have set my active area extents, but I can also specify a separate rainfall area. So that constant inflow, or when we get to the direct rainfall, is only going to be falling essentially within that rectangular area there. So I'm going to process that, and I'm going to populate the rainfall area as my rainfall area model. And again, I can come in and I can override the values because it scans that model and shows me all the polygons within that model. Everything is light grey in here, so that is just using a pre-populated value, so I don't actually have to fill anything in there, but maybe I want to change the name of that for all of my analysis and all of my simulation. So if I go ahead and hit set and finish, that's populated that as my defined rainfall area. And I'm going to run that one more time. Okay, that's now complete. I'm going to read the results in again, and we'll go and have a look at what setting that rainfall area has done to the actual model itself. So I pop into the plan results. It's a little bit more difficult to see that the rainfall is only being generated from that particular model, because we do also have some water escaping out of that. But if I go into the inputs and add that results 3D and toggle off the contours, okay, you can quite clearly see that the rainfall has started within that rainfall area and then is now being distributed downhill from there. So there's no rain falling in those areas of the grid up above in the upper catchment. Right, let's go and have a look at a couple more features of the 2D water analysis. If I look down in the area down here, there's a gully, but in the plan results there's not a lot of action or water or any flooding happening in that lower area. So we're going to take you through the grid water levels and the initial water level settings within the 2D water analysis. If I want to get an idea of that tin, if I inquire on the height of that tin in that area, we're probably looking panels might actually show me, there we go, we're looking at about an RL of about 30 down in that gully down there, coming up to about 31.5. So what if I wanted to model over the entire grid area if I had an initial standing water level at the start of my run? So back in the geometry tab, we get the ability to enter an initial water level for the entire grid, and I'm going to put that as 31.5. Okay, so we start with essentially some ponding or some flooding areas there. And when it comes to the basins, we don't have a lot of action happening in this top eastern basin. There's not a lot of water entering it, so it's contained within the storage. What if I wanted to set some initial water levels? Those basins are not empty to start off with. They're starting off with some standing water inside them. So again, if I go back to the inputs view and I add on a model called initial water level, I have two polygons created and two polygons drawn where I want to set initial water levels for items in a model. And if I have a look at the heights of those in the inquire, I have some Z values that are already on those strings. Okay, you don't have to have Z values, but it is a little bit handier when you do. So I can set an initial water level polygons model. So if I choose that model of the data that you can see on the screen, again, I can go and edit or override the values of the strings within that model by clicking on the edit button, and it has some light gray values, so it's showing me those initial Z values from those strings in that polygon, and I can override that if I want. So if it's gray, it's a pretty populated level, but let's say I go 44.25 on that one. If I hit set, okay, that should be black. Okay, so that's now a solid black color, so I can see that that's been a manual override, and that will go and set the appropriate attribute value, but it won't reset the Z values of that string. All right, let's run that and see the impact of the initial water level on grid and also the initial water level polygons onto our simulation model. Right, that's another run in the bank. Let's go and have a look at the results of our initial water level settings. So if I read the results in here, previously we had not a lot happening in the lower portion of our simulation area, and we had very little water that was escaping out of the eastern pond. So now that we've set initial water levels in that pond, you'll see there's a lot less storage and there's a lot more flow essentially coming straight through there. In our lower area, you can see the effects of the initial water level flooding in the lower reaches of our simulation area. So those are the initial water level functionality that you now have within the 2D water analysis. What we'll look at next is a couple of things. We're going to change the rainfall information from just a constant rainfall to a rainfall distribution, or we'll call it a temporal pattern at the stage. And we'll also look at some of the other geometry modifiers before we do another run. So if I go into the rainfall tab, rather than having a constant rainfall, I want a direct rainfall. So I'm going to change the constant rainfall to 0. We have some initial losses for our rainfall distribution, so I'm just going to put a couple of numbers in there. And before I enter a hydro file, you'll see that this terminology has changed. This is now a rainfall distribution, so that's actually what's correct. It's the distribution of the rainfall onto the grid depending on the method that you choose. So the methods have also been renamed, and you'll see the tooltip there. There's a double line tooltip. At the moment, I see all of the available options. The temporal pattern distribution, the variable pattern, so an Auckland TP108 storm or the NZSCS, the variable temporal pattern for the SCS methodology, and the historical rainfall depth. And all of those are going to be explained in detail inside the help rather than go into them now. But the important thing is, at the moment, I see all of the values, but as soon as I choose a hydro file, it's going to scan the hydro file and see what are the available values within that hydro file itself. And now when I come back to it, I've obviously only got only got temporal pattern rainfall distribution within that hydro file, because that's all I see. Now what I'd like to do for this next run is I actually want to run multiple storms or multiple temporal patterns. So I'm just going to fill that in and put a frequency of 100. And I could edit the hydro file here. I could open that up directly from the panel. And you'll see at the moment I have one temporal pattern selected, which is my CCC 60-minute storm. And the zone filter is important to note once we complete this next run. Just showing some other couple of new features within 12D Model version 15. Rather than actually edit the hydro file, I could update those within the new option under Water Stormwater Dynamic Analysis. It's the rainfall event selector. So rather than going tick, 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 or waiting for a hydro file to read, this rainfall event selector, I can just simply choose the hydro file. I need to put in a frequency and hit enter. But then I can come and have a look at the actual storms, and this allows me some really clever ways to select or deselect the rainfall or the storms that I actually want to run. So I could do the normal tick like I do within the hydro file editor, or I can hold down control and select multiple things. I can unselect them all, or I can click and drag, and that's just going to much easier rather than ticking 200 options. Set those storms. So I'm going to run a 30 and a 60 minutes. So if I apply that and set, it is actually updating the hydro file in the background. So if I come back to the hydro file and hit read, and go back to the temporal patterns, you'll see I do have the 30-minute and the 60-minute. So that is updating the hydro file from the rainfall event selector. So another little tool that you guys can have a play with. I'm just going to minimize that because I will come back to it. So this time for the simulation, I'm going to run the direct rainfall on grid, running a 100-year intensity from the hydro file. So if I go ahead and hit run, and we'll wait another 20 seconds or so. And then have a look at the results of this simulation. Now this one will take a little bit longer because I'm running 2 storms, so I appreciate your patience. Okay, that one took a little bit longer, but I promise you it will be worth the wait. Now when I hit read results on this one, everything's going to disappear. And you're going to go, well, I'm not too sure what's going on here. Why has everything disappeared? It's just reading the grid check files for the last time. If I refresh that view, everything's gone. And it's because now that we've run a direct rainfall and we have multiple simulations, being able to trace exactly which values in the model names is automatically incorporated again based on the sim file name. So now when I go to the add model, I still have my top level tree, I still have my results 2D, but I now have two different time periods. I have my 30-minute time period and my 60-minute. The automatic naming conventions takes the duration, it takes the storm name, which was the CCC, and then puts in the duration at the end. So I have multiple results that I can add into different views from the different hydro file simulation periods that were selected. Now I am going to hold on to the 60-minute one, so I'll add the 60-minute to both of my views. But I think you can see that with the automatic file naming and the automatic model naming convention in the background, it just makes your life so much easier and somebody else's life easier to see exactly where those values have come from. And while I'm talking about the file naming, I haven't shown you that. If I go and have a look at the files in the background that have been created, I didn't have to enter a folder name. Everything is being done automatically in the background. So I have my flood 2D only, exactly the same as the sim name, and all of the associated files that are needed for the simulation contain that sim file name, so I can trace that. Right. So if I go into the run results, I did have a water-eye WRB and a WRC selected, so those are those files there that have been created. But you'll see everything automatically takes the simulation file name, which makes it so much easier for coming back to a simulation after a number of days or even a number of months, loading the sim file and getting an idea of where everything came from. We'll be running through a couple more simulations. Before I do run those other simulations, I do want to bring that rainfall selector back up again wherever it's gone, and just set that to a single storm so we don't have to wait as long for our simulations to finish. So if I go back to stormwater, dynamic analysis, rainfall event selector, choose that hydro file again, put in a ARI or a frequency. I'm just going to go and unselect the 30-minute storm and only run that single storm from now on. You still have the same geometry modifiers that you had in the 2D quick analysis tool. So if I just, actually I'll work on the check model for now, just remove the grid. Okay, so you've still got your ability to set your ridges and your gutters or your gullies model. So if I just turn on the ridges, I'm going to work on this one for now. So I have a 3D string that I want to modify based on the Z value of those strings to modify my cells. And of course, with the SGS, you pretty much don't want to use the gutter strings. You want to use the ridges. So I have the 3D string here, and I'm going to specify that as my ridges model in the geometry tab. Now I won't run through the whole analysis for these ones. I'm going to stop it early, just pretty much because I want to show you what the check models have. So I'm going to specify that ridges model, and I'm going to hit run, but don't worry, you don't have to wait this time. As soon as it pops up, I'm just going to finish that simulation a couple of times to show the check models that are added. So the check models, I just want to read in the results. And I have another additional couple of check models that I can add on, my Z shape and my Z shape modified Z. So hopefully they're a little bit more explanatory for you. But this just gives me an indication of where that Z string has modified my cell. So this works for thin lines, and it obviously works for thick lines. If you've never seen that before, I'll just toggle off the line styles. And I'm going to go and just change the string properties quickly, because I want a band of cells within that area to be applied. So I'm just going to edit all of the segments on that original ridges model, or that ridges string, and I'm going to set a pipe for that, and that pipe determines the width that it's going to modify your grid cells. So if I put a pipe diameter of 3, okay, you can see that I've now got a thick or a fat line, And again, I'm just going to run it just enough so I can finish off, so we can reread in those check models and have a look at what the fat line has done. Right, if I read those results again, where we previously were affecting single cells within that area, you'll see from our check files when I refresh, we've now got potentially multiple cells that are affected by the width or the diameter of that line. And the last run I'm going to complete and wait for this is I'm going to add in my final geometry modifiers. So depending on your 2D Open license that you have or your existing external 2Flow license, whether you can use Quadtree is completely dependent on your license. So I'm just going to nominate a Quadtree model, and if I have a look at that model here, where I'm going to specify my Quadtree area, and if I add on the grids in preparation, that'll be the last time I'll be reading in the grid cells, hopefully. So I'm going to nominate the polygons within that model as my Quadtree areas. And I'm going to go and run the simulation. Okay, so last time reading the results with the grid check files. And you'll be able to see from those grid check files how the Quadtree has been enabled. What we're going to run through now, our final simulation, so before I forget, I'm going to untick that read grid check file, is how easy it is to make multiple variations of different simulations because you don't have to fill the panel in all again. So all of the simulation settings, I'm just going to save that for now. So this has purely been a 2D only, but what if I want to do a coupled 1D 2D analysis? So I want to keep all of the settings but add some settings to it as well. So I'm simply going to come in and type in a brand new simulation settings name. So I'll call this flood network. Remember to hit enter, which will create that sim file. And I have all of the same settings. I'll just save that before I forget that I had before, but I'm going to add some additional settings and we'll start looking at coupling our 1D 2D network as normal inside 12D. So if I go back to my inputs, and this time I'm going to add on my network models. So I have a water network that's basically all set up. That water network has some additional catchments assigned to it. So if I turn on the catchments and the catchment labels. Okay, so this time the inflow into the bottle is going to be coming from my 1D water network, having those catchments and some potentially user-defined inflows. So what I'm going to do is I'm not going to do a direct rainfall. I'm not going to double up. All of my inflows are going to be coming from my network model. And before we run this for the final time, what we'll do is we'll have a quick look at the network itself, where we've got some catchments and some other potential tools that you may want to use. Now you may have seen either in the tech forum or in some of our videos, you might have seen the concept stormwater designer. So I could edit these network in a couple of different areas. I could use the concept stormwater designer, or I could use the water network as well. First off, I'm going to fire up and have a look at this 1D network in the concept stormwater designer itself. So I'm going to load up that model. So where this water is getting flow from, I do have a bypass node here, which will more than likely be overridden once we get the point spatial flows in. But if I have a look and edit that node there, I do have some restricted or some user defined inflows. So we've got quite a bit of flow that's going to be coming down that gully. And we've also got another option that's got a couple of catchments assigned to them. So if I go down to this node down here and have a look at the catchment data for that particular node, okay, we have a catchment polygon with some catchment parameters and percentage imperviouses and whatnot set. So that's where our 1D water flow is going to be coming from. Now, like with anything, you want to, if your 1D network is not running okay, then your coupled 1D, 2D network is just not going to work. So what I'm going to do is I'm just going to double check that, and I'm just going to run that 1D network, make sure everything's absolutely fine before I couple it together. It is, it's great. We'll just close those error warning reports. Yes, I have reviewed the problems. Got a few of them sitting up there now. So I could edit that in the Concept Stormwater Designer and have a look out for the webinars and the videos on the Concept Stormwater Designer, because it is a really great editor that works hand in hand with the 2D water analysis. If I didn't want to do the Concept Stormwater Designer, I instead wanted to do my Water Network Editor, of course you can do the same thing in there. So the Water Network Editor, if you're familiar with that, just want to double check that everything's all set there, not a problem. Okay, so I've still got my catchment number 3 set. Yep, everything's fine. I'll go and run my analysis just to make sure I haven't upset anything. And then we'll come and we'll couple these to our 2D active area. Perfect. So one more simulation run, but this time all of the flows are going to be coming from my coupled 1D network instead. So I have my network model set, my storm event frequency, everything's as per because I was using the same file. So for the last time I'm going to go and run. Now this will have a few more cells that will be active, but if you bear with me, this will be the last time we run the simulation. Now, the main reason I ran a coupled 1D, 2D network and made you wait through that is just to show you the intelligence and the differences in the model names. So again, you can have your model tracing a lot easier. So in my plan results, I'm just going to remove the 2D flood only. And let's have a look at the new object tree group that has been created for my new sim file called flood network. Okay, so my flood network. Oh, sorry, read the results in. Okay, go back again. I was going to forget to do it sometime. Because it is a coupled 1D, 2D network, the model names are different. So I have a checks 1D, 2D, and I have a results 1D, 2D. So if you're picking up somebody else's simulation, it's quite clear that the data that you're looking at in that view has come from a coupled 1D, 2D model, because they might have two variations. They might have one without the 1D network and one with the 1D network. So you're not going to pollute or disturb those results. They're going to be sitting there by themselves. So if I turn on the results 1D, 2D, it's my 60-minute storm from my CCC temporal pattern, and I'll add on the 3D results. And now we've got quite a bit more flow coming down. Our culverts are actually in play, so any flow that's going over land is now running through the culverts, but we still have those initial water levels being affected as well, so that will definitely be affecting the tailwaters downstream of that culvert. So recalling and saving a sim file is the last thing we're going to do. Is I finish off that error warning report and save the sim file before I close. So you've closed your project down, you're coming back a few days later, you need to rerun the simulations. It's as simple as going up to water 2D, 2D analysis. You can choose the sim file from the list. And as soon as you choose that sim file, because it saved all the values and settings, you're all ready to go for rerunning, changing values, and doing that network. So we'll just pop back for a little bit of a summary, and then I'll take any questions that you may have. All right, we'll pop back to the PowerPoint presentation just for a second. Run through a very, very quick summary of what we've been through. So the 2D water analysis, it builds on the user-friendly graphical user interface of the Cook analysis. It extends the features and the commands for your 2D modeling requirements, and those commands, the ones that we've put in initially, have come directly from feedback from our users. The simulation file is brilliant for the tracking and the file and model naming. It is a single step process, so you won't be using the 2D quick analysis if you've got access to the 2D water analysis. The pre-population of values saves time entering in values in the panels. And lastly, it's a context-driven option, so you only see what you need based on what you've selected. So thank you for your time, and we'll pass back to Lisa and potentially take some questions from you. So thank you very much.
Thanks for that, Dylan. Yes, we have had a couple of questions through, and I think I sent you through a message about just turning up your mic volume a tiny bit too. We just had a comment about that. So
yes, hopefully this will be better.
Oh yeah, that sounds a bit louder. Great. So good. So Daniel has asked, what is the reason only the top area is used for the rainfall area and not the whole active area?
That was just purely to show you that you could have individual and different valued rainfall areas. Yeah, you'd probably want to do it on the entire grid, but having the ability to have separate or individualized rainfall areas, or you could even have a polygon, let's say if you're doing at source attenuation from a building and the building's never going to get into runoff, it just allows you to almost exclude those areas from the rainfall coming from the temporal pattern or from the rainfall on grid.
Okay, thank you. And we had one through from Scott. Where do you specify multiple Manning N values?
Oh yes, now that is one thing in the PowerPoint slide. I did say there's 3 things I wasn't going to show you today because they're under development, but I'll show you on the panel. They're just not active at the moment. So in your Manning's N value, just like these other ones where you have a model selection and you have an edit button, in 12D model C1S, which is the next release, there will be that button active there. Sorry, there. I'll hit the control button. No, wrong button, which will allow you to enter in, I'll say unlimited, but it is limited, but there's probably a couple of thousand, but be able to enter multiple models with different polygon areas and give those different Manning's N values. So that's one of those features that I highlighted of the 3 that I wouldn't be showing you today. But yes, that is definitely in there to coincide with this initial Manning's N value, because that's another thing that our users asked us for that they can't do in the 2D quick analysis.
Thank you. And I might just do one more live for today because there's a few others, but well, I think I'll email those through. So
Sure.
we've got one from Nikki. With the temporal patterns used, can you still add a fixed initial water level in the swale?
Yeah, absolutely. So you'll see that last run that I did, and I had that initial water level on the grid and the initial water level within the basins. That initial water level has been coincided with when I was doing a direct rainfall, or even when I was doing the coupled 1D, 2D network. They are still in play as they are part of the simulation setup.
Wonderful. Thank you for that, Dylan. And I'll so yes, I've got a few more questions I'll send through to you shortly. And the
Lovely.
recording of today's webinar is going to be available in coming days through the webinars page on our website and on our 12D Model YouTube and Vimeo channels. I will email that out. So I think a couple of people have asked about the recording. So I will send an email to everyone who registered as well. So that'll make it nice and easy to access. And keep an eye on our emails and social media for details of our future webinars. And if you haven't seen it yet, the dates for the 2026 12D Tech Forum have now been released. There's a special discount still available, so you can check out 12dtechforum.com for details of that too. And of course, our website's always got our contact details and everything if you need anything in the meantime. That concludes today's presentation. Thank you all for attending, and we hope to see you at future webinars.